Okay, Chapter 9. Try to make Chapter 9 a little faster than Chapter 5. You've probably learned about me by now that once I start talking about this stuff, it's hard to get me to stop. But I'm presuming you guys like some of the details, some of the exposition, because you guys you don't get the lecture discussions, so it's probably nice for us to discuss these things. Okay, so number one is really three problems at once. It's having you solve it by graphing, by substitution, and by elimination. And usually you wouldn't be asked to do all three of those things at the same time. But make sure you can use all of the techniques. You might be asked specifically to do it by substitution. You might be asked to do it by elimination, often called addition method. So you want to make sure you can use the technique you're told to use and that you look for that. I always hate taking off points for not using the right method, though I do it, but it always makes me feel bad. So graphing, just, set these equal to y and graph the lines. You guys know how to graph lines. And you just pick the point where they're intersecting. The disadvantage for graphing lines is it tends to not be very accurate because it's only as accurate as your graph. The advantage is it's fairly fast. So if you're wanting just a quick value or a quick approximation, graphing them is really nice. So, do practice making sure you can graph your lines. Please be sure you can graph your lines. But if you're, but I'm not going to go through it. Substitution or elimination are our methods to get nice, secure, solid answers. So for substitution, we want to pick one of the variables to solve for. And really, you could solve for any of the variables here. You could divide by the 5 to solve for... Now let's go ahead and solve for y. Let's do that. Divide by the 5 to solve for y. You could solve for this x, that y, anything you want. None of them are really great choices, so we might as well solve for this y. It's almost done anyway. So once you have that, you plug it back in for the y in the other equation. So this equation says that 6x minus 4y should equal 14. But we use this one to say y should equal all this stuff. So y should be, I'm going to write that, if you don't mind, as 2x over 5 minus 12 over 5. It'll just make it a little easier to work with, equals 14. So once we solve this, all we have now is x's. We can solve this. Once we have this, we'll know x. We can go back and find out y. So, distribute that 4 real quick. 6x minus 8x over 5 minus 48 over 5 equals 14. Remember, we're multiplying by 4 over 1. I don't like those 5s, so I'm going to multiply everything by 5. 5 times 6 is 30x. 5 times 8 fifths is 8x. 5 times 48 fifths, the 5's cancel. So 48 equals 50 plus 20, so 70. Clearing fractions, hopefully you remember that technique. Clearing fractions, awesome, very handy technique. So we get what, 22x minus 48 equals 70. Oh, I forgot to distribute this negative. I should make that positive, and that positive, and that positive, and that positive. Careful about that. Negative 4 times negative. None of you said anything. Negative 4 times the negative makes that a positive. So that's a positive, so that's a positive. Glad I caught that. Be careful about those things. So 22x, we got to subtract the 48. Subtract the 48 gives you 22. So divide the 22, divide the 22, and x equals 1. X equals 1 is, of course, not our answer. It's half of our answer. Answers to ordered pairs should be, answers to systems should be either ordered pairs if there are 2, or ordered triples if there are 3 variables. So we got to go find the y. Luckily, we know what y equals. Y should equal 2 times the x value, which is 1, minus 12 over 5. So, 2 minus 12 over 5? So y equals negative 10 over 5. So y equals negative 2. So our answer should be the point 1, negative 2. And that's what, our graphing looked like. Anyway, so 1, negative 2 should be fine. So substitution. Here, we solved for y because it was almost done anyway, but you could have solved for any of the variables that you wanted. Now, this is kind of like 1c, where this is 1b, where 1a is just drawing the graph. So you're also asked to do the same problem doing elimination, again, sometimes called addition method as well. The big difference for elimination method, one, it helps if they're both in standard form, so I'm going to subtract that 2x from both sides just to put it in standard form. But also it kind of helps avoid some of that fraction work along the way, like my multiplying by 5 to clear the fraction. Some of you are more comfortable with that than others. If you're not real comfortable with the fraction work or just aren't in the mood, this methodology can eliminate some, not all, of that fraction work. So to do elimination method, we have to pick a variable to get rid of. We could get rid of the y's by multiplying the top equation by 5, the bottom equation by 4. That would make this negative 20 and positive 20, so they would go away. Or we could get rid of the x's by making them both 6's. We could make it a 6 by multiplying that bottom equation by 3, so that's probably simpler. So that leaves the top as 6x minus 4y equals 14, turns the bottom into negative 6x plus 15y equals negative 36, I think. Yeah. So 6's go away just like they were supposed to. We get an 11y equals negative 22. Divide by 11, divide by 11, and y equals negative 2. Yay, we're done. Okay, no, we're not. We still need to find the x value. We only have the y value here, so substitute it back into either of the equations. Doesn't matter which one. I'm going to use the top one. 6x minus 4 times negative 2 equals 14. So 6x plus 8 equals 14. Subtract the 8. And 6x equals 6. Divide by 6, divide by 6. We get x equals 1. So same point we got on our graph, same point we got while doing substitution, should be the same answer, we're all good. And again, in general, you would use one of these 3 methods. We often do, you'll kind of do substitution, get an answer, and see if it makes sense on the graph. This is a nice way to check yourself really fast to make sure your answer seems sensible. But for most technical applications, you need something more accurate than graphing can give you. But like if you're using your calculator, have your calculator graph them and find the intersection using your calculator's intersection tool. It will give you only an approximation, but that's okay. So you could find this 1, negative 2 pretty exactly by plugging those as y equals into your calculator and asking it to find the intersection. It would give you the 1, negative 2. It won't find exact answers if it's from some horrible irrational number, but it'll get you pretty close. Okay, so that's number essentially 1, A, B, and C. Number 2 is also kind of giving you 2 parts. It's giving you do it by addition and using the matrix. I'm going to be presuming here that you guys know how to do the matrix. I'll talk about the setup, but the whole what keys to push, if you don't know, watch the videos. Make sure you're remembering how to do that. But generally, you'll either be asked to either do it by addition, which means show all the steps, and you will be asked to do that. But in other problems, like the word problems, will mostly be set it up, or no, just set it up and leave it alone, or set it up and use the matrix to solve it. But you will be asked to do at least one by hand, so be prepared to do that. So just so it's a little easier to see, I'm going to copy the problem down here. Bear with me. Okay. Now, just like elimination method before, addition method and elimination method are essentially the same thing. We need to pick one of the variables to get rid of. In the problem before, wrong one, sorry. We picked the x's to get rid of, so we made them match so the x's would go away. We're going to want to do the same thing here. Pick either x, y, or z as a variable to get rid of. The only difference is instead of doing it once, we're going to have to do it twice. So if you pick getting rid of the x's, you'll have to do it twice. The x's do disappear nicely with this pairing, but not as nicely with either of the other two pairings. So the one will be nice, but a second one won't be so nice. The y's aren't nice. None of the y's are nice. But this negative 1z is really nice because multiply it by 4 and it will get rid of this. Multiply it by 3 and it will get rid of that. So I'd probably pick z's. But you could pick x's. Heck, you could pick y's if you want to. You know, it's your problem. Make it as bad as you want it to be. So I'm going to get rid of the z's. I like to label these. It helps with reference. You don't have to. The organizational scheme I use for this is just that. It's my organizational scheme. You can organize it however you want. But staying organized is a big, big, big key with these. So if we want to use a and b and get rid of z's, we're going to need that to be a negative 4z. Already has the negative, so all we need is the 4. So we're going to take a and 4 times b. You see how I'm writing that? Take a and 4 times b. So 2x minus 2y plus 4z equals 14. And 3, multiplied by the 4, 12x plus 16y minus 4z equals 28. And then we add them together. The z's go away just like they were supposed to. We get a 14x plus 14y equals 42. And usually I would just say that's our next equation, but noticing that this is a 14 of 14, and that's, what, 3 times 14, it might be nice to simplify that a little bit. You don't have to do that. You'll take the 15 out, the 14 out later, either way. But if you happen to notice it's got some common factor, it's nice to take it out. Like we could have taken a 2 out of this just to begin with and simplified our whole life. But taking that 14 out is nice. Get x plus y equals 3. And that's a nice little equation to work with. And I'm going to call that equation D because we're going to reference it later. Okay, equation D has 2 variables. To solve for 2 variables, we really need 2 equations. So we really have to build a second one that just has x and y. That's what I meant by having to do it twice. We did a and b. We need to pick another pairing and make sure we get rid of the same variable both times. We want another xy equation so we can solve D and that other xy equation. If we get rid of z the first time and then x the second time, it's not going to do us any good. So you really need to pick a variable and stick with it. We're getting rid of z's, so get rid of the z's. But 3 times b and c makes that into a negative 3, so it will get rid of that positive 3. Should work. So what do we get here? 9x plus 12y minus 3z equals 21. And negative 2x minus 3y plus 3z equals 4. Again, this organization method is just how I like to organize them. Organize them however works for you or has worked for you, but some sort of organizational scheme can be really helpful. So add those together, 7x plus 9y, those go away, equals 25, and that's E. So D and E both have x and y's. I have 2 equations, both with x's and y's. We can solve this new system, DE. We could use substitution if you really wanted to, but since we're doing kind of the addition method style, let's take D and multiply D by either negative 7 or negative 9, depending on which variable you want to get rid of. Again, it's up to you now. We got rid of all the z's, so now we'll get rid of either all the x's or all the y's. Let's get rid of the y's. Why not? So we need to take E then and negative 9 times D to make that y a negative 9y, so we'll cancel with that 9y. Again, negative 7 on the D would work just as well too. So E is still 7x plus 9y equals 25, and negative 9D is, well, negative 9x minus 9y equals negative, what, 27? Yeah. So the y's go away, just like we planned. Negative 2x equals, negative 2. Divide the negative 2. Be real formal here, so x equals 1. Yay! Sorry. Yay! Now, it would be nice if we were done there, but certainly we're not. Our answer should be a triple. It should be an x, a y, and a z. We found the x. We got to go figure out the y and the z. Now, the nice thing is we don't have to do all this work over again. We have a relationship between x and y. We actually have two of them. So if x equals 1, we could put it into here, x equals 1, and find y. We could put it in here to find y. Do whichever one's easier. I'm inclined to use D. So let x equal 1 in D, and we can find y. So 1 plus y equals 3. Subtract the 1, might be overdoing this here. So y equals 2. Yay, we found x and y, we're done. Okay, we're not done. We still need z. But we have relationships. A, B, and C were relationships between x, y, and z. We know x, we know y, all we have to do is find z. So pick one, either A, B, or C, to use to find z. Again, it doesn't matter which one. Because of that nice z, I think I'm going to pick B here. So, again, let x equal 1 and y equal 2 in, I said B, so use B. But again, A or C would work too. So 3 times 1 plus 4 times 2 minus z equals 7. So 3 plus 8 minus z equals 7. 11 minus z equals 7. Subtract the 11, or just say it's 4. So negative z equals negative 4. Divide the negative 1, divide the negative 1. Again, might be overkilling that. So z equals 4. So our solution, our answer, is 1, 2, 4. Oops. Sorry about that. You missed all that, didn't you? Sorry. So we let x equal 1 and y equals 2 in equation B. B, because I liked B. So 3 times x plus 4 times the y value minus z had to equal 7. So 7. So 3 plus 8 minus z had to equal 7. 11 minus z has to equal 7. You might at this point just say, hey, that has to be 4. But to be formal, subtract the 11, get negative 4 equals negative z, divide the negative 1. Either way, we get z equals 4. And our answer is our nice ordered triple. Okay, to do that with the matrix real fast, matrix, you're just putting into your calculator your matrix augmented with your solutions, your coefficients, and your solutions. So your matrix is going to look like that. And then you're going to ask your calculator to put it in reduced row echelon form. And that reduced row echelon form should look like 1, 0, 0, 1, 0, 1, 0, 2, and 0, 0, 1, 4. Because again, these are all your x's, your y's, and your z's, right? So 1x equals 1, 1y equals 2, 1z equals 4. That's your solution, your x, y, z. 1x equals 1, so x is 1. 1y equals 2, so y is 2. 1z equals 4, so z is 4. So be able to do that with your matrix operations within your calculator. But you will be asked to do it by hand, so do make sure you're able to do it by hand. Okay. I'll see you soon.